Astronomer. And as usual, we have our trusted astronomer just a few doors down from me on unceded territory of Musqueam, Squamish, and Tsleil-Waututh, and that is Marley. Hey, Marley, how's it going?
It's good. I'm very excited for today's presentation.
Yes, we've got some special guests, as everyone can see from across the country. So you may remember a few months ago, I was not here at Ask an Astronomer in May. I went to Lethbridge to support the Canada CanSat competition. We were in Lethbridge because just outside of Lethbridge there are these flat lands which you can actually launch rockets from, and that's exactly what we did. And there were teams across Canada that came to Lethbridge to release their CanSats. And so we've got one of those teams, Team Swordfish from Bayview Secondary in Richmond Hill Secondary. So we've got Jeffrey Zwang, we've got Jacob Shi, Fiona Kai, Olivia Huang, and Louis Gao, as well as another member of the team that couldn't make it today, Ethan. So thank you all so much for joining and coming on Ask an Astronomer.
Yeah, thank you so much. We'll just introduce our roles real quick. I'm Lewis, and I'm the team captain.
Hi, I'm Jeffrey, and I work on the software and hardware.
Hi, I'm Jacob. I worked on the hardware.
Hi, I'm Olivia and I do the social media.
And my name is Fiona, and I work mainly on the software.
Awesome.
Sorry.
Thank you guys so much for joining. So what we're going to do today is you folks are going to tell us about your project. Tell us, what essentially what we did, out there in Lethbridge, what a CanSat is. So if you're out there watching on YouTube land or even Instagram, if you've got any questions for these folks and their amazing project, put them into the comments, and then we'll ask them. We'll also have a little bit of time at the end with Marley. So if you have any question under the universe that you're curious about, put those in the chat as well, and maybe we'll include the folks from Team Swordfish to see if they can answer some of your questions under the universe. So I'll hand it over to you, Lewis, to let us know all about your CanSat project.
All right. So, we're Team Swordfish, and what exactly is a CanSat?
So the word CanSat comes from the combination of satellite and a can, since our satellite is in the shape of a can. And so it's a 300-gram payload launched on a rocket to 1 kilometer, and it's ejected and descends from a parachute. And while it is descending, it collects data from various sensors to complete a mandatory primary and a secondary mission that we were able to choose ourselves.
So here's a video of our launch using the high-power rocketry at Lethbridge.
Very cool. This was very exciting. There's so many of these launches, and I had before last year I'd never actually seen some of these launches, but yeah, up to 1,000 feet in the air, right?
Right, 1,000 feet. It's actually there's a lot of acceleration, and apparently you need actual certificates to launch those as well.
That's right. So we also partnered with the Calgary Rocketry Club. A lot of those they did have certification. So of course we didn't actually get to do a lot of the launching, but you guys got to hand over your CanSat to them, and they did the launching.
Right, and here's a video of our onboard camera of our CanSat. You can see the ejection process and a little of a descent, which is pretty neat.
Very, very, very dizzy.
Right.
I guess a question for you off the top here, Lewis. As you watch that video, were you able to get that footage like in real time, or did you have to wait until you got your CanSat to land to like get that footage back?
Yeah, for this footage, we have to wait until CanSat goes back. It's stored on an SD card on our camera. The raw footage is like 4K, so it's way too big to be transmitted down.
Okay. Yeah, well, tell us about your missions.
Right. So, how do we get involved initially? Actually, we have a quite interesting story. My dad first saw from WeChat that the past winners were looking for sponsors for their program or for their trip to Europe. So I looked at the competition. I thought it was quite interesting. So I talked to a few people. I talked to Fiona, who was the best software engineer I knew, and she was interested. I knew Jeffrey as the missile kid who builds. Anyways, he just sits at the back of the classroom. He always either on KiCad or on 3D modeling. So we know him, the missile dude. I knew Ethan So as the treasurer, and he's very good at economics. I knew Jacob was very good at software, and I knew Olivia had very good outreach skills. So ultimately, I just gathered these people, and I thought, why not? And I think the most important aspect of these people is that I knew everyone would work really hard on the project together, and so I think that's what pushed through the team. And
Awesome.
so as for CanSat, the Canadian tournament competition, everyone would have a primary mission where you would measure air pressure and air temperature and altitude during descent and transmit through radio. And for our secondary mission, we chose terrain relative navigation. Spacecrafts that are landing on other planets, such as sending a rover on other planets, they don't have GPS because they don't have that satellite system built in. So they must rely on other navigation methods. Terrain relative navigation is one of those other methods. So it takes pictures of the ground and compare with a map to allow the spacecraft to figure out where it is. And here's
cool.
a quick footage to show you how it's in action. And there are many instances where you don't have GPS access, right? So you can underwater on caves or, for example, on other planets, and that's where TRN comes into play. Why do we choose TRN? Jeffrey, you wanna?
So back in grade 9, I was building a drone and I didn't have a GPS receiver. So I went onto the internet and I asked a dude who had multiple PhDs about alternatives to GPS. And he introduced me to terrain relative navigation. I was looking for alternatives to GPS because I thought GPS modules were expensive, so I didn't want to buy one. I didn't think GPS was accurate enough, and coincidentally, I already had a Raspberry Pi and a camera. So I thought to myself, terrain relative navigation shouldn't be that hard, right? Right? So I tried it out, and it turns out I was very wrong on all 3 occasions. It did end up working somewhat, and there's the video on the slideshow. But I really wanted to try it at higher altitudes, like 1 kilometer, like a real spacecraft. And so a few years later, Lewis came and told me about CanSat, and it was the perfect opportunity to try terrain relative navigation at higher altitudes on a real rocket launch. So that's how we came up with the secondary mission.
Awesome. And I should point out too that in the competition, every team has the same primary mission, but every team gets to choose their own specific secondary mission. So this was your collaborative choice to go to this route, right?
Right. And there's actually right now in the real world, a lot of other companies are like Draper, NASA, Astrobotics. They're currently working on to improve this technology to make it more robust and work under tougher situations. And yeah.
Awesome.
Yeah, you can see here. So they're trying to make the technology more robust.
So this is a 3D model of the CanSat. As you can see, there are a lot of components, custom printed circuit boards that we designed in order to complete the primary and secondary missions. For example, the onboard computer, and you can see the camera at the bottom there. There's this hole for the camera so that we can actually record the footage and complete terrain relative navigation. It's a lot smaller than you might imagine at first, at 6 centimeters diameter and 200 grams. We eventually had to add another 100 and something grams to make weight.
Right, so what we have accomplished is essentially in this video. So we're able to correlate the descent image with a picture to do this terrain feature recognition part. Fortunately, there's some other stuff we didn't consider, and our flash memory actually didn't work. So we didn't have the accelerometer or gyroscope data, so we can't calculate the exact position. But in terms of terrain relative navigation, the as you can see on the video, the recognition part is actually the most important part.
Very cool.
And
I just have a question.
right.
Are those green lines, are they corresponding to like that deep dune to the deep dune in the still image? Like that's what it's using to write itself or acknowledge where it is in space.
Right. So what happens is on the right is a fixed image, obviously, and on the right is the live video. So the the green lines, as you said, correlates the features to each other. With this feature, we can figure out how much it rotates, how much it has moved, how much it translated from the original image.
Mm-hmm.
And in a in a real launch, NASA would use something like a satellite image on the right side. So our experiences during the tournament, actually it was really interesting tournament, because other than just a tournament itself, it's like a 5-day experience, if I recall correctly. We get to visit Lethbridge, and I think we also went to during nighttime we went to a observatory nearby, and it was during nighttime. It was a little cloudy, unfortunately, but we still got to see the Northern Lights, and it was obviously really cool. I get to talk with a bunch of amateur astronomers, and yeah, I mean, uh, I I I think actually the most important part of this uh competition is the interaction with other teams, and you get to meet with all the other teams that are also interested in this subject, and they also know so much about that they are willing to commit to a competition like this. And there's a lot of knowledge exchanging process. The more you talk to them, the more you realize, we're like-minded, and so it's a few, you make a few friends that maybe can last a lifetime. There's also quite a few challenges we have faced, quite some hilarious situations. So, 2 weeks before the actual competition, we fried our initial CanSat. So we were quite devastated. We we thought, maybe we couldn't do anything about it. But yeah, eventually we pushed through with with some money and to buy a few extra components. But yeah, eventually we pushed through. There's a lot of silly mistakes. You would think those memes about, small semicolon, they don't exist, but it's some stupid mistakes. And obviously our CanSat being lighter than the minimum requirement was a surprise. So we had to send two of our group members running around Lethbridge hunting for metal washers to just add weight. And lastly, there's a few issues with, expectation versus reality, where stuff in theory on paper it should work, but when it comes to reality, some sort of random stuff happens, and you don't know what to do. And so, for example, our flash breaking down and stuff like that. Oh, and what do we plan on doing with the CanSat in the future? So first, we would want to fix for our CanSat, there's a small issue during the startup process. It's not optimal, so we want to fix that, and obviously we want to fix the flash issues. To upgrade our CanSat, we want to have better radio and better package structures, so we can have higher frequency data sent down instead of just having to read on an SD card. We're going to drop from a drone to test our CanSat. And lastly, I think the most important or final goal of this whole project is to make terrain relative navigation work in real time. So we would have all the processes, instead of doing it on the ground, we do it on board the CanSat and let the CanSat figure out where it is as it falls. And that's like the final mission.
Awesome. Well, thank you so much, Lewis and Team Swordfish. This is really cool, and I should also note that you both won, your team won the Technical Achievement Award sponsored by Telesat. I just saw their logo pop up there, but also the Best Science Mission as well. Earth Daily Analytics sponsored that, as well as your sponsors for your team here. So it was an amazing competition. We've got a few more minutes with you folks. What I'd love to hear from some of the other team members is, what you got away from this experience, because it sounds like you all were really working as a real life situation like space engineers do when they're working on missions and they've got deadlines. And like you said, a week before you have these disasters that happen. And Marley could certainly tell us lots of stories of real world things that go wrong. We actually even have a story of something that a real world thing that's going wrong. But let's go to like maybe Fiona, if you want to maybe say a few words about some of your takeaways from this amazing experience.
Yeah, so prior to this competition, the only type of engineering I guess I ever did was software engineering. And so this was my first time working on anything that related to hardware. And something about software is if something breaks, it doesn't cost you anything usually to fix it. But in terms of hardware, if something breaks, like you actually have to go outside and walk to a store to find some washers. Like you can't just download it from some other website.
Right.
And so that was a very new experience. And something else I took away was going on actually traveling, because after COVID, I actually had not stepped into an airplane like since COVID started. So that was quite an experience just getting to Lethbridge itself.
Yeah, and that a bit of a shock if you'd never been to Alberta before?
Well, I've been to like the Banff kind of route, but I've never been to that part of Alberta.
Okay. Well, Marley knows lots about it. She's from Calgary, right? It's a beautiful Calgary, right, Marley?
Yeah, beautiful and cold and or in the middle of construction always. It's my home and I love it. It's just Southern Alberta, you know? It becomes a desert the further you go.
Well, what's interesting about Lethbridge in that area that we went to is that it does seem to have like sort of like temperate climate, so it doesn't have huge shifts. Although one of the things that is a concern is that if they don't have rain and the land gets quite dry, the fire marshal will actually come and say if we can actually go ahead and launch rockets or not launch rockets, because it could start fires in the region as well. So we had great conditions because it actually had rained just before we got there. So it was perfect rocket launching conditions, which also meant that the whole Rocket Juke Club brought on there's lots of people there beyond just sort of like what the competition was. Some of them testing on new rockets. Some of them were getting their accreditations because it's kind of like flight school. You need to have like so many flights before you can actually get your rocketry certificate. So it was really exciting. Let's go to a few other people as well. Maybe Jacob, maybe talk a little bit about your experiences.
Yeah, well, this was definitely a new experience. I've never tried making something with a group like this before. And certainly we learned a lot about teamwork. And as you mentioned, with all the challenges we faced along the way, the improvisation that's necessary to sort of make do with what you have. There were some issues that we couldn't resolve because of time, and we sort of just had to put everything together to make the best product we could, because there are real deadlines to these things. Like on launch day, we have to launch, you know.
Yeah.
But yeah, it was really fun, and I've also never seen a rocket before, so that was new.
Awesome. Yeah, and Lewis, you had said that you had sort of like you had brought these people together. Did you know everyone? Like you had kind of like these are all people that you knew from school.
Yeah, but there's a lot of people that I know them, but I don't really, you know, I didn't really know well. But I
Right.
feel like after this tournament, all of us are gonna be quite friends for a long time.
Yeah. And what was interesting too about your team is that you have brought on someone like Olivia, who you said had more of a social media skills, which is something you wouldn't normally think about, in an engineering competition. So Olivia, maybe you want to give some of your experience and what skill sets that you brought in, what you learned as part of this experience.
Yeah, so like you mentioned, aerospace and satellites aren't something I typically dabble in very often. So I think this is a really nice learning opportunity for me to partake in. And it was very nice to work with these amazing group of people. And I think that I learned a lot from them, such as like Jacob mentioned, perseverance. And I believe that in terms of what I brought to this team, um, well, I think I brought like some creativity in terms of like our Instagram posts. And it was also like, I guess being able to like give a fresh perspective on some problems we had was also pretty important. And I think I learned a lot more about problem solving and I guess to have a growth mindset when facing challenges.
Yeah, for sure. And I think that's a really important thing about when putting together teams like this is I think you were smart to bring in someone like Olivia that did have a different skill set and someone that could look at problems from a different point of view. Sometimes what often happens in teams is that you bring too many people that have the same kind of mind, that they think all the same, and they're all looking at a problem, they're all trying to think of it, solving the same way. So having a diverse team can really help out. Finally, Jeffrey, what was your main takeaway from this experience?
Yeah, so this is like the first time I've worked on a complicated project in a team, in a small team. So it was nice having other perspectives and other people for solving issues. Sometimes when I'm working on a project myself, I'm like stuck on it because I think it's this one thing, and then if there's other perspectives, then they can see things that I can't. Yeah. And also just like debugging issues and solving new challenging and challenges problems and things like that. Yeah.
Awesome. So we actually I do have a few questions from the audience as well before we go over to Marley. So so Keith asks about the write-ups of the presentations for the teams. So talk a little bit about sort of like the reporting and the writing reporting that you had to do for your project.
Right. So for the competition, there's the mandatory ones so there's a CDR quite a few months before the actual launch date where you have to write a little sort of overview on what you do, and then there's another report you have to write. I believe it's around a month before the launch, where essentially it writes almost exactly what you do, what you did. You have to explain in detail what your mission is, your what you have done, the challenges you faced, and actually I forgot to mention that there's actually an outreach component to this competition where you have to present to 3 different groups. One would be like an elementary school group, one would be a secondary group, and lastly an adult group. So yeah, we have done that. We persuaded to a few schools, and yeah, and then we wrote about how it was really interesting to see the interests of these different groups, where you have elementary school students who's interested in the fun stuff, the robot, the actual rockets and stuff. You have secondary interested in technology, while the actual adults at the logistics. Anyways, sidetracking. So during the in Lethbridge, there's a presentation you would do to present your 15-minute presentation to the judges and to other teams about your competition. Sorry, about your mission, your CanSat. And actually, the day after the launch day, you have to put together a report on what you have actually, your results of your CanSat. So it's pretty cool. I mean, you're presenting to judges who are in the field, who knows a lot more than you do, and you're trying to explain what you do. And yeah.
Yeah, great. Well, wonderful. Again, thank you guys so much for joining for today's show. Congratulations on a successful project. I hope you continue along with this, and as you continue on with your careers, which may extend into university, you all are probably well on your way to being very successful in whatever you do. If you want to just stop sharing your screen, there you go, Lewis. We've got one final little story that we can kind of make it a real world, because in the real world application, a lot of these CubeSats and CanSats do get released from the International Space Station, right, Marley? We've got some news as to what's happening up there.
Yay. Hopefully this loads in a reasonable amount of time. Excellent. So yay, Team Swordfish. This was really fun. I enjoyed learning all about like how this works because Michael talks about it all the time when he's here, but it's nice to actually get like the people who are building the CanSats and doing the team stuff as opposed from like the judges event host perspective. It was very cool. It's a good project. Well done.
You didn't believe that I was actually going somewhere. I was thinking I was just trying to get a day off, going to
I mean,
Lethbridge.
like, no, I believed you, but I was like, this, I want to know what the kids are doing. Like, this is Michael's version. I want the kids' version. Anyway, so what's going on the space station? Well, if you remember from like last year when I last spoke about this, there is the Starliner, which is the Boeing capsule that is meant to carry a maximum of 7 astronauts or a mix of crew and cargo. It'll land on solid ground and it has an autonomous docking system. So this is meant to be a capsule that will help get astronauts and crew to and from the space station so they're not relying entirely on the Soyuz spacecraft or relying entirely on the Dragon X capsule, right? Like an additional part to the space environment. And this had a crazy timeline. They were super, super, over budget and super delayed in what they were wanting to do. So last year when I spoke about this, we were looking at a April 2024 launch for the first crewed test flight. And this ties into Canadian, work in this field because Joshua Kucherick is supposed to be on the first official crewed flight, not a flight test, like the actual first flight. And he's currently working as Capcom or was working as Capcom for this mission. So this was heavily delayed. You can watch the episode from last year because that was the last time we talked about it. And it did not launch in April. It launched on June 5th. So it finally launched. The Starliner got up into space, which is only half of the battle. So on board are 2 astronauts, Butch Wilmore and Sunny Williams. Both have experience. They're NASA astronauts. Sunny has actually been an astronaut for as long as I've been alive, so she knows what she's doing. And Butch Wilmore also has been an astronaut. He was selected as an astronaut in the year 2000. So they are very experienced, well trained. They are still up there. So this mission was not supposed to last as long as they've been up there. They were supposed to come back, I think it was June 13th. They are still currently on board the ISS. So en route to the ISS, they detected 3 different helium leaks on the service module of the spacecraft. 1 was known, 2 were new. So 2 new leaks had popped up, and then 5 of their thrusters went out. So in space, this whole Newton's laws really take over, right? An object in motion will stay in motion unless something else acts on it. And so spacecraft have these thrusters to enable them to do precise movements and also to prepare for docking. And so they ended up getting delayed with docking, did finally manage to dock. And while they're on board the space station, they've been doing safe haven checks, which means checking out the spacecraft, making sure that it could support a crew with its own air and consumables during an emergency on the station, as well as evaluating some other things like how their spacesuits fit, how the seats fit. Could you work with 4 people inside of this capsule? They also then found there were 5 small helium leaks. And so ground control, NASA and Boeing have been looking at that and a problem with one of the valves. So far, everything is okay. The spacecraft still works and it was cleared for crew emergency return scenarios. And this became very important very quickly because yesterday, a Russian satellite broke up in space, which forced the crews on board the ISS to shelter. And where they shelter are inside of their respective spacecraft. So aboard the Dragon X capsule, and Butch and Sunny would have sheltered inside of the Boeing Starliner. And this is done for emergency purposes. If something happens to the space station and the crew needs to return home, they're already inside the spacecraft that will bring them home. NASA did come out and say that this was more of a precautionary measure. They weren't in any immediate danger, but they still would have been woken up in the middle of the night to an alarm saying, get inside, like emergency procedures, because this would have happened probably when they were asleep. And after an hour, they were cleared to exit the spacecraft. So it ended up being okay. The U.S. Space Command put out this statement here, confirming the breakup of a long-defunct Russian satellite. And it occurred at an altitude that the space station was at or near, which is why there was all the concern about any possible consequences to the crew and to the space station.
So, and then, of course, this gets back to like why, space debris is such a serious issue, not only for the safety of the International Space Station, but for all other satellites that this debris could smash into, right? So, is there any other danger for anything else besides the ISS?
I mean, they were able to find, I think it was 100 pieces of trackable debris. What they're not saying there is there's a lot they can't track, right? So the smaller the piece, the harder it is to track around in orbit. So that can affect other satellites. The biggest one we're always worried about is the risk to human life, which is why the ISS carries so much concern. But there's also the Chinese have their own space station. The Chinese space station is up there. And so they may have also been alerted and meant to, shelter in place and may have similar procedures. They're not as open with communicating that, but I assume it would be similar. Like that, those are still their people, those are still their astronauts. You want to keep them safe.
Awesome. Well, thanks, Marley, for that update. And that about wraps it up for this episode of Ask an Astronomer. And thank you to Team Swordfish joining in from the East Coast, representing Bayview Secondary from Richmond Hill. Thank you all so much for joining Ask an Astronomer. And to all of you, I put into the link if you want to know more about the CanSat competition, but also the university level CubeSat competition, CSDCMS.ca. You can go there for all of that info. We didn't even really talk about CubeSats a whole lot, although Marley and I do talk about them in relation to a lot of the Artemis missions that come up. So we'll talk more about them in future episodes. We will be back again here with another edition of Ask an Astronomer in 2 weeks. That is going to be July 11th. Same bat time, same.
Here. I'm not here. I'm not here.
Oh. Well, what are we going to do?
Matthew.
We're going to have Matthew. Okay. All right.
Yeah.
Okay. Well, Marley is not going to be here, but I will be here in 2 weeks. So join us then with another edition. Thank you all so much. See you then.